Welcome to our next session of online class, children. Now I have a question for you. Listen to me carefully, okay? Think about it and try to give the answer, okay? Now I have a metallic rod on my hand, in my right hand, and on my left hand I have a paper. So metallic rod is having more work function and paper is having less work function. Okay. So here metallic rod, electrons are tightly bound when in comparison with paper here. Okay. Right. Now I am holding in my right hand metallic rod, left hand paper, and I am standing on the floor with a bare foot. Okay. Now I am rubbing the metallic rod with the rubber. Whether I can charge the metallic rod by doing this? Think. I don't know whether you got the answer. Okay. Now the answer is no. Why? Because when I rub, electrons do transfer from paper to metal. So, but once the charges are transferred to the metal, I am holding the metallic rod. Therefore, human body is a very good conductor. So, the charges which are transferred on the metallic rod, immediately it will go through my body, it goes to earth because I am standing on my bare foot. Okay. So, therefore, now what will happen? You cannot charge the metallic rod by doing this. Okay. So, next case. I have same metallic rod, paper, everything is same. I am holding it, but I am insulated from the earth, insulated from the ground. Earth means what is insulated from the ground. Okay. So, now what? I am standing on a wooden plank. I am standing on a wooden plank. Therefore, now insulated from the ground. Now, once again, what I am doing? I am rubbing. Now, whether there is any chance of charging the metallic rod? Even now, no. Why? Because once the charges get transferred from paper to metallic rod, but since I am holding, human body is a good conductor, all the charges immediately will goes, through my hand, it goes to my body. But it won't go to the ground. Why? Because it is insulated. I am standing on the wooden plank. So my body will absorb all it goes through my body. So metallic rod cannot be charged in this case also. Then whether there is any other means? Okay. Yeah, what is that? You can. Okay, how? See, I am keeping a metal rod on, okay, and I am holding it by means of a it is kept on a insulating stand. Okay, metal rod. Now this what I am doing now with the left hand, I am having a paper in my left hand, but let me have a gloves. I am wearing a gloves also. Why? Because by chance if any of the finger it touches the metal rod, immediately charges once again it will go through my body. So I don't want to don't want that. So what I am doing? I am having a gloves. I am wearing the gloves and I am having a paper. Nicely I am rubbing. Now what will happen? That because of this there will be exchange of charges. That is a transfer of charges. Okay, and now the metal rod, for example, electrons get transferred to the metal rod. Therefore, the metal rod is now isolated from, it is insulated. Therefore, you can say that you can charge the metal rod by this way. Okay, but it should be insulated. Okay, so that if you are rubbing also, what will happen? It may go to, but once it is going, the charges will be uniformly distributed in the metal rod. It won't stay at the same place. If the insulator means, if you are giving some charge to insulator, the charge will stay there at the same place. Okay, but once the charge is given to the metallic rod, then charges immediately it will be distributed uniformly on the throughout the body. Okay, that is a reference. Is it clear? So this is what I wanted to give now. Next topic is, okay, comparison of charge and mass. And mass. Okay. Now, see, you know very well mass plays a very important role in gravitation. Like that charge plays a very important role in what is electricity, electricity, right? Now we are dealing with electrostatics, of course. So now we are going to compare. Okay, let me list it. What is that first one? Okay, charge on a body, see, body, okay, may be positive, negative, or zero, neutral. Okay, charge in a body may be positive, negative, or even zero. But mass of a body is always positive. Okay, so you cannot say negative mass definitely is not possible. Zero mass is also not possible. Even electron, very, very tiny, but it has, what is that, mass of 10 power minus 31 kilograms. So definitely mass will be always positive. Number 2. Okay, see, charge of a body is independent of its velocity, whether the body is at rest or moving. Okay, so it is independent, the charge will be the same. Okay, but here mass increases with velocity. How? M, by the equation M is equal to m naught divided by root of 1 minus v squared by c squared. What is it? M naught here, it is a rest mass, when the mass is at rest. M is the mass of the body when it is moving with the velocity v, where v is comparable to that of c. C, as usual, it is velocity of light. Therefore, by this equation, you can say that, okay, by substituting, what will happen here? You can say m will be more than m naught. Therefore, mass increases with velocity. Okay. Next one, third one. Third one is charge. Okay, is always conserved. It is conserved. That is, what is that? Q is equal to plus or minus NE, where N is equal to, what is that? 1, 2, 3, etc. Therefore, it is always, sorry, it is conserved. So, I am quantized ending. Sorry. This is what. Charge is always conserved. Okay, this also be one of the property of the charge. Okay, charge can either be created or be destroyed, but can be transferred from one body to another body. Therefore, net charge of a system is always constant. Isolated system is constant. Okay, but mass of the body, okay, is not conserved. Why? The reason is mass can be converted into energy and vice versa. E is equal to mc squared. So, mass can be converted into energy and vice versa. Therefore, you cannot say mass is conserved. Okay. Now, next one, fourth one is charge is quantized. Here only, what is that? Q, that is equal to plus or minus NE, right? But here, what is the charge? What about mass? Yet to be established. This has to be established. We don't have idea. Okay. And fifth, force between charges, okay, can be attractive or repulsive. Okay. How? See, if two charges are like charges, positive, positive, or negative, negative, definitely they will repel each other. If one is positive and other one is negative, means they will attract each other. So, force between charges can be attractive or repulsive. But force between masses is always attractive. I think. Okay, gravitational force are always attractive forces. 11th standard you have studied. Okay, then next one. Next is, you know that, what is a unit? Okay, unit of charge. Let us get unit of charge. Is coulomb, and unit of masses. What is that? Kilogram. Correct? Then 7th one. I think this you will study after later. An accelerated charge, when a charge gets accelerated, it emits radiation. Okay, so that can also be given here. An accelerated charge emits radiation. But here, an accelerated mass emits no radiation. That's it. Emits no radiation. Okay. So these are all main differences between charge and mass. Okay.